All right, so before we do the quiz, guys, let's look back first at the topics that are covered in the quiz. All right, and this is also going to be part of the test. That's why we're recording this review, because I'm going to put it as part of the review for the test. All right, the first thing you need to know, guys, again, is counting the number of atoms. All right, so again, when you count the number of atoms, guys, you focus on two things: the coefficient and the subscript. For example, here, there is no coefficient, so you only focus on the subscript. So how do you do this? Again, just list down first all the elements that you see: carbon and oxygen. Okay, and then you look at subscripts. Carbon doesn't have a subscript, so it's just a 1. Don't forget, there's no subscript, just put down 1. Okay, look at O, it has a subscript, therefore it's a 2. It's that simple. Okay, what if there's a parentheses? All right, let's take for example, guys, Ca3 parentheses PO4 parentheses 2. Okay, so again, you want to list down all the elements: Ca, P, and O. Right, how many Ca's do I see? 3. Okay, how many P's do I see? All right, if you look at P, guys, there's no subscript, so it has to be a 1. All right, but Celia's right. It's actually a 2. Why is that? Because it's inside the parentheses. So you have to multiply it by the number outside that parentheses. So it's a 2. So actually P is 2. All right. And then O, if you look closely, is a 4. But again, it's inside the parentheses. So therefore, multiplied by 2, you actually get 8. See it? All right. That's correct. Now, why is counting the number of atoms super important? Well, because we need it for getting the molar mass. So, for example, the question was calculate the molar mass of CO2. All right, guys, if you look here, guys, as soon as you see the word mass, remember for the next few problems, if you ever see the word mass or grams, okay, remember we're talking about, you need to keep in mind that you have to calculate for the molar mass. And again, what is the molar mass? It's the mass of 1 mole of a substance, in our case, CO2. Okay, and you want to find out how many grams is that. And again, how do you do this? First of all, list down the elements, C and O. Again, you got 1 C and 2 O's. And then you have to multiply these by their atomic mass. The mass of C is 12, and the mass of oxygen is 16. Okay, C is now 1 times 12 is 12. And then oxygen, 2 times 16 is simply 32. What do you do with these two? You just add them all up. So this is now 44. And that's the molar mass. Okay. All right. It's important, guys, that we write it down this way, because this will become our conversion factor when we try to convert moles, okay, to grams if the number of moles is less than 1 or is bigger than 1. So this is the conversion factor that we need. All right. So again, don't forget, as soon as you see the word grams or mass, you have to calculate, guys, the molar mass. I'll give you an example. For example, guys, let's say the question is, how many grams of CO2 are there in 2.5 moles of CO2? All right. So again, as soon as you see the keyword again is grams, you must do the molar mass calculation, which we already did. So I'm just going to write it down again. 1 mole of CO2. And remember, we just did this earlier. 44 grams of CO2. All right. So how do you set up this problem again? Remember, the first thing you need to do is draw those grids. Okay. Remember, you have to do the grids. Okay. There is nothing ever, forever underneath the first bottom box. Okay. On the top left box, it's going to be your given, and it's going to be the number inside the problem. So it's going to be 2.5, right, moles of CO2. See it? All right. Now, what goes in the next boxes? All right. Even though you only have 2 sets of boxes in the next one, you may have 6 more. So what goes in those next boxes, right? After the given, all the boxes will have what you call the conversion factor, which is Simply, in our case, our molar mass calculation, this thing right here. Okay? So if you look closely, there's two parts, the 1 mole and the 44 grams. The question is, which goes where? Who goes on top and who goes at the bottom? All right. And the answer is dependent on your given. Look at the unit. We said boxes across diagonally, they have to have the same unit. So the bottom should also be moles CO2. All right. And look at your conversion factor. All right. Moles CO2, it says there 1 mole CO2. Okay. And remember this, and this is a good thing to remember. In the conversion factor, guys, it's always going to be 1 mole. It's always going to be 1 mole. All right. So where does the 44 go? It's going to go on top. Okay. When the units alternate, it allows us to cancel it out. So the moles CO2 cancels out. All right. Now what do? You just multiply, guys, the top number. Okay. 44 times 2.5 is 110. And look at the unit, grams of CO2. Multiply everything at the bottom, but you only have 1 there. And so divide 110 by 1, you get 110.0 grams of CO2. Okay. I just added the 0. I just added the point 0 because most of our answers will have one number after the decimal point. See it? Okay. Y'all look. Guys, the 1 mole here in the conversion factor is at the bottom. Is it always at the bottom? No, it's not. It depends on the question. So let's look at another example. So look at this one right here. Okay. So for example, guys, the question is how many moles of CO2 are there in 88 grams of CO2? Again, I see the keyword grams, therefore I need the molar mass. 1 mole of CO2 is equals to 44.0 grams of CO2. Okay, now look, we're going to set this up. So again, you should know the setup now. There's nothing at the bottom. The given goes at the very top. In our case, it's 88 grams of CO2. All right, now look closely now. Where will I put the 1 mole now? Is it still going to be at the bottom? No, because look, the unit of the given is grams. So therefore, that's right. The 1 mole is going to be on top now because the grams CO2 has to be at the bottom. So look, okay. So 1 mole now goes on the top. Very good. And then the 44 grams of CO2 goes at the bottom. Again, doing so allows us to cancel out the units. Okay. You multiply everything at the top. 88 times 1, you get 88. And the unit will be mole of CO2. And then you multiply everything at the bottom, but it's just 44. And 88 divided by 44 is simply 2. Okay. And the unit will be moles CO2. Okay. See that? All right. And again, you should have, if the direction says it, you should have a number after the dot. It's going to be 2.0. Okay. If we are rounding off to the tens place, it's going to be a 2.0 moles of CO2. See it? All right. Now, wait. Is it always going to be the grams that's going to be the key word? No, it's not. Okay. So, right. So if you look at this problem right here, the key word here is not grams. It says there how many molecules of CO2 are there in 2.0 moles of CO2. Again, the key word here is molecules. Again, guys, if you ever see the word molecules, atoms, okay, or particles, any of these three, what should come into mind is the conversion factor of 1 mole, okay, equals to 6.022, or just stay at 2, it's up to you, times 10 to the 23rd power. All right, what will be the unit? Okay, the unit will be whatever is the keyword. So this will be molecules. The keyword here is molecules, so that's going to be the unit here. Of what? CO2. So this is 1 mole of CO2. That's our new conversion factor, all right? So again, the keyword is particles, atoms, or molecules. You use that. Okay, and again, draw the grids to solve this. Draw the grids. Nothing goes here. The given goes in the very first box. Okay. And then again, you choose which one goes on top and which one goes at the bottom. It depends on the given. Since the given is mole CO2, 1 mole CO2 should go at the bottom. And then the 6.02 times 10 to the 23rd power molecules of CO2 goes on top. Nope, it's a bit long. All right. So again, the mole CO2 cancels out. Okay. 2.0 times 6.02 times 10 to the 23rd is simply, I'm going to put it down here, 1.204 times 10 to the 24th power molecules of CO2. And since the bottom is simply 1, guys, that's already the final answer. You see it? So again, it all depends on the keyword, right? And it still follows exactly the same way you determine who goes on top and who goes at the bottom. All right, now focus on this one right here. What if there's more than one keyword in the problem? Okay, you all look here. What if there's more than one keyword in the problem? It says there, how many grams of CO2 are there in 1.204 times 10 to the 24th molecules? Okay, what if there's two keywords? That means you have to use both of them and get two conversion factors. So again, if you ever see the word grams, you have to do 1 mole equals to the molar mass. And we already did this for CO2. Molar mass of CO2 is 44.0 grams of CO2. Okay, again, if you ever see the word molecules, okay, you do the 1 mole of CO2 is equals to the 6.022 or 6.02 times 10 to the 23rd molecules of CO2. All right. What does this tell us? There's two conversion factors. That's basically what it is now. There are two conversion factors. All right. Which means you still follow exactly the same way of solving it. So first draw the grids. Okay. Oh, that's too small of a grid. Let's put it right here. And write down your given. There's nothing here. Don't forget. Write down the given in the first top box. It's 1.204 times 10 to the 24th power. Okay. Molecules of CO2. All right. Now look, in the next two boxes, guys, you need a conversion factor. The question is, which one do you use first? Is it the 1 mole equals molar mass, or is it 1 mole equals to 6.02 times 10 to the 23rd? Okay, it all depends on the unit of the given. So look at it. The unit of the given is molecules CO2. So I have to look for one that has molecules of CO2. So look, which one has it? It's the one in blue. So we're going to use that one first, the molecules. Okay, so who goes on the top and who goes to the bottom? Again, boxes across each other should have the same unit. So the 6.02 times 10 to the 23rd power molecule CO2 goes at the bottom. Don't forget that. Okay. Yeah, 6.022. But I just got tired of running down the other two, so I just rounded it off. All right. I'm rounding it off right now. But if you want to put the other two, that's fine. Okay. And then the 1 mole goes on top. All right. CO2. We're done with the first conversion factor. So we're good with this one right here. So you don't need this anymore. We're done. All right. So what happens now? How about the other conversion factor? All right. That means you have to add another set of boxes. Don't forget. If you still have conversion factors, you just add them. You just add more boxes to it. Okay. All right. So now I have 1 mole and 44. Where does 1 mole go? At the bottom. And why is that again? Boxes across diagonally must have the same unit. Okay. And then the 44 grams goes on top. Okay. All right. So how do you put this in a calculator? Just multiply, use parentheses, guys. To make your lives easier, just use parentheses. Parentheses, put everything on the top, multiply everything at the top, close parentheses, and then you divide it by everything at the bottom. So multiply everything at the top, multiply everything at the bottom, and divide the top by the bottom and get the final answer. Okay, what will be the final unit first? Okay, let's see. The molecule CO2 here cancels out this one. The mole CO2 here cancels out this one. So you're left with grams of CO2. So G, okay, of CO2. Whoops, 2. All right. So what will be the answer? If you put this in a calculator and you do this correctly, the answer will be 88. All right, grams of CO2. And that's how you do these conversions. Again, it all depends on those key words. You got me? Okay. Let me just